And then when there is no argument at all, it will be smallest on top. Let's see that. We have the first insertion in here. So we only have -2 and that's it. We don't have anything. So it will be on the top and -2 in here. Then we will insert -7. It will be on the top. Why? This is how it works. So this will be our second insertion. And we'll have -2 added by -7. Since the smallest on top, -7 will ask the question, am I smaller than my parents? My parents -2. And the answer is yes. If I'm smaller, and I will become the parent, so -7 will go to the top. And this will be in here -2, and this will be -7. This is the final form of the second insertion into priority queue. Then we will see for the next one is, what happens if we insert -4? Well, -4, let's see that in here. This is the third insertion, -2, top to bottom. So we already in here, and then we go to -7, left to right. So we go -4. Am I smaller than -2? And -4 will ask the question, am I smaller than my parents? The answer is not. I'm not smaller than my parents. So I'll just happy in here. Let's go to the fourth insertion. At the fourth insertion, what do we have? We have -1. Where does -1 go? It's just on the bottom. So this is a good way to see that we get from the top to bottom, -4 to -2, and -7, -2, -4, and in here we done left right, we go to the bottom of -2, we have -1 in here. Okay, sounds good. And we will add -8. What will be the position of -8? It will be on the top in here. The question is like, how does the -8 will go on the top? So at the fifth insertion, we got -7, -2, -4, -1, and -8. This is the first form, and -8 will ask the question, am I smaller than my parents? The answer is yes, so I need to change. So we got -7, and then -4 in here. This will be -8. Then we will have -1, we will have -2 in here. Okay, and -8 will also ask the question until the answer is a no. So it's kind of recursively asking question. Am I smaller than my parents? The answer is yes. So -8 will be in here, and then this will be -7, -4, -1, and -2. So this is the final form of the fifth insertion. Then we will add -1. Where does it go? It just go at the bottom. So at the sixth insertion, we have -7, -2, left and right, -4, then here -1, -8, and -1. So we are going to read that is -7, -2, -4, -1, -8, and -1. Just like what do we have in here? So we are all good with the priority queue right now. I kind of want to, I'll make a separate video, but that's for later. Anyway, let's go back to the last stone weight in here. So we will initiate the object of the priority queue that we call max heap. And in here, and we will add the negative stone. Hence, we have this kind of the order. And then we will keep looping until the max heap size, as long as the max heap size is greater than 1. Okay, let's go into the loop. Stone 1 is we take out the small, well, kind of large over there, but since the algorithm negative, we take the top priority. Let's say that. So we take the -8, and then we will take also -7 for the stone 2, And then stone 2, the same with the stone 1, same with the stone 2? No. So we will add the remainder, which is stone 1 minus stone 2. Negative 8 minus 7. 8, negative 8 plus 7, that is negative 1. So in here, we have a max heap with the size of 4, and we will add negative 1, and that will be on the bottom in here. Okay, cool. Does our max heap size still greater than 1? Yes, it does. So we will take the top priority in here, which is like the smallest because we have the negative 4 as the stone 1, and negative 2 as the stone 2. And then we will crush them. And are those the same? No. So we will stone 1 minus stone 2. Minus 4 minus 2, so that's also adding into minus 2 in here. So minus 2 will go on the top based on that priority queue. Do we need to draw it? Let's draw it. So in here we got the negative 1, negative 1, negative 1, and we will add negative 2. So it will rearrange into something like this, negative 1, and then this is negative 2, this is negative 1, and then this is negative 1. So negative 2 will ask another question, am I smaller than my parents? The answer is yes, so he will go to the top, then the rest is just negative 1. So this will be the priority queue if we hit the next button in here. Yep, negative 2, and the rest is negative 1. And we will keep looping right now negative 2 against negative 1, so it will be just negative 1. So we will have a heap element of 3, and all of them are negative 1. It is still bigger than 1, so we just keep doing it right now, negative 1 with the negative 1. If stone 1 is equal to, it's not equal to, if this is false, then we just end the loop. That's it. So right now the max heap size is greater than 1. We will return the size. If it is not equal to 0, we will negate it to remove the last one. Or if it is 0, just 0. So how do we read it? Return the max heap size. If it is not equal to 0, we will return the first one behind this column. If it is true in here, we will return 0. That's kind of how to read it. And then we got the expected 1, and the result is 1, and that is true. So that is the 1046 with the priority queue.